Okay. Right, got it. The only thing interesting about this program, it's pretty much normal in every way. It's got the same controls that we have, and it does everything everything we can do, it does. What it looks like a top, but really what it is, it's a curve, a mathematical curve that's been spun around like that to form a shape. And that can be done in this language. It can be done. We haven't done any of it because I'm going to show you why in a second. But basically, you can color, as you can see, I can shine a light on the top of it and get one color. I had the left and right lights. I changed them. I moved one underneath and one above, and I made one blue and the other one red. So you can see what it does. It has that. It changes the way it looks. It's kind of cool that you can have this kind of effect. And I also use the shadows, so you can see the shadows down there at the bottom of the thing. You can also, if you look very closely, you see a bunch of little wiggles. You see those little wiggles there? There's a thing called anisotropic. It's kind of it's a technical thing. These wiggles aren't supposed to show, but these computers are so bad, and probably the pressure on them so great that they can't do what they have to do. Basically, what happens is this structure is built on a lot of little triangles. And what they did is, as they build the triangles, if they don't use this anisotropy on it, you actually see the shapes of the triangles in the form. So what they do is they sort of blend it out for the screen so that it looks nice and smooth. The whole idea is to give you a smooth image of something that's really not smooth, okay? And it's an extra step. And it turns out I've applied this thing here, and I unapplied it, and it doesn't seem to change anything. So the computers may either not respond to their version of it, or maybe some computers do and some don't. But in this particular case, I'm not getting a very good result because, as you can see, we're getting wiggles. Down here, we're getting wiggles and on the edge of it. Wiggles here because the shadows are wiggling, and wiggles there because the triangles are actually showing, which is not very good.
So it's supposed to be, in a perfect world, a faster running machine, like you have this on a gaming PC, it would be more fluid.
Yeah, I don't think it's. It could be a question of faster because it might be able to calculate the thing better. But you know, this thing does have a problem. When you animate something, it has two choices. It can either construct everything that you want constructed and animate it, or it can say, "Oh, time's up," and just get out there with whatever it has. I'm not sure which 3JS does. It might do one or the other. I'm not sure which. But they all have that problem because if they wait for you to construct everything, your constructions may be so long that it loses the. I don't know why they advertise. I own a virus. I don't know why they keep advertising at me. But maybe that's the problem. But the thing is, you have to everything you do in this 3D world it's still in limbo. Nothing has been decided yet. They're still constructing. They're still inventing. They're still doing a lot of work in it. That's the reason why there aren't 10 courses in this around the country. There's only this one. I don't even know if there's any others. There's probably not another one someplace. Because this particular thing is so new, nobody has really had time to analyze whether it's really worth sticking to or not. My view of it is JavaScript is not going to go away. 3JS is not going to go away. And so therefore, whatever they change it into, it's going to be based on this. So we're going to be living with it no matter what. So the idea is I think that this is ahead of its time. To make a long story short, I don't expect you to write this kind of code. You can if you want to. You can steal this, just like you take any code from my stuff. You can take this code too. There it is, right there. Can you read that? Anybody can read that? Do you want me to bring it up a little bit?
3.textureloader.load.
How about now? Is it a little better? Whoops, not like that. But I mean, can you read it better now?
Stripe height.
Well, here it is. You see where it says start spinning top code? And it says end spinning top code. Everything about that top is actually in that code right there. And I'll show you what they do. These are things that you haven't had to deal with because all the stuff we do between WallMaker and the simple ways that we have of making spheres and everything, all that's been refined so you don't have to worry about all that stuff, a lot of stuff. But let me show you what kind of happens behind the scenes, which I've never actually talked about before. And by the way, another thing I want to say is, this is what happens behind the scenes that I'm doing and 3GS is doing. Behind those scenes, there's another behind the scenes, which is WebGL, which all this stuff is sort of an easy version of that. And then behind WebGL is machine language, which is even a harder version than that. So it's like these layers of things. We're writing in a top easy language, and it gets more difficult by the guys below us and below us and below us. It gets much more difficult. But the whole point of a telephone is be able to talk on it without having to worry about the undulating electric current. So you don't want to be dealing with this kind of stuff. You get in the car, you start steering it, you don't care about the cylinders and everything. And this is the same thing. The computing is getting like that. They're trying to get it so that everybody is away from the technical stuff. The only reason why I'm dealing in programming is because there are some things you can't get any other way. Now, there are programs that will design characters for you, plenty of those around, and there are programs that will even animate little characters for you. But when you see how they work and what they do and how much effort there is, you're basically programming to start with because they can't get away from it. It's complicated. And the second thing is the stuff they produce is limited and pretty junky. Unless you actually become a programmer, you have to, make little boxes and blocks and things. So this is about as good as it gets, because in this case, this leads to heavy programming. So you could extend what you're doing here and actually produce very refined stuff. You don't have to unlearn anything. Everything is part of the system. So my idea was in the beginning was just to introduce the basics of this, to show you how it works and get an idea. But let me go behind the scenes here for a second before I start the review. First of all, this is the instruction right here that normally says I want to use this picture. We just write the name of the picture and the code, and it takes it and it does all this stuff to it. When it gets it behind the scenes, it takes your picture and it does this to it, which is there. So what it does is it makes a map. It's going to plaster onto some object, some three-dimensional object, okay? And then it says, take the map, wrap S, that's it, that's the wrapper. It's going to wrap it around this thing, around the object, whatever it is. Then it puts it in the anistropy, which says, okay, you're going to draw triangles, and you're going to put texture on top of it. Don't show the triangles, just show the texture. Make it nice and smooth as you can. So it has a little program. This is what WebGL does behind the scenes. We don't even see that. Then I say, now that you've got this map, make a material. Plaster that picture on the object. Now you got the material, which is called map. Take that map and plaster it on actually put it on the object. And that's what this line here does. It says material equals mesh Lambert material. Lambert is there's different kinds of lighting for these things. They have lots of different ways of calculating the lighting, and Lambert's one of the kinds. It's one of the kinds of lighting, and it works good with materials, with texture. So they use that one for this one here. It says on this mesh, use Lambert lighting for the material. That's what it says. And then all these things like map, side, 3 double side, and all that stuff. What that says is when you put texture on a square or something, if you go on the other side, you can still see it because it's on both sides. What it says is double side the texture so that it goes right through it. It is possible to put texture on one side and not see it on the other side, let's say. But that seemed like less useful to us than this. So I did it this way. It seemed like it was a more useful way to do it. The points are these, as I said, this top is designed by a curve. It's just a simple curve. And what the points is, it's the points along that curve. And what I say is, okay, make these points. Here's something we haven't talked about, which normal programming courses do talk about. This is called a for next loop. What it does is, it goes from for, this thing here, to this right here, this brace right here. It repeats that over and over and over and over again as many times as it has to. So what it does is, I starts at pi, and then as long as I is less than 0, it says I is plus blah blah blah. So basically it's minus pi, by the way, minus pi. It goes from minus pi all the way up to 0. As long as it's less than 0, it keeps repeating over and over again. When it hits 0, it stops. So what it's doing is it's making these points one after the other till it gets to the point where it stops and says, okay, that's it. The curve is complete. And then what it does is it goes down and it says, it gives the name of the object, which we normally call, we say a variable object name. We give it, the blob object is just the name we give it. And then it says, okay, take the mesh and plaster this is the actual instruction. It plasters the material on this new mesh, which is spun around. And then it says, finally, add that object to the scene and show it to us. That's all the stuff that actually goes on. There's a little more too, because with videos, this is only a JPEG. With videos, you got to do a little bit different. You got to do more stuff. So behind the scene, if you look behind the scenes of what we're doing with our graphics XX, you see this kind of code all over the place, because this is kind of what happens. And this is the first time I show it to you, and the only reason why is because I don't intend to use this in graphics XX. I'm just going to show people kind of what it looks like. I'm not actually putting the points down. I'm putting those points in a curve right here, in this cosine. Putting I into this cosine, doing a bunch of calculations. That's because I taught trig for a long time, and I know how to make a funny curve. And so I said, okay, I'll make this funny curve, little cosine curve, nothing special. But so it could be any curve, any formula could be in here, but you'd have to find one that actually produces the numbers you want. And that's it. That's pretty much all there is to it. Then I went up above. It's called BL object right here. Then up above, in the universe above, right here, I say BL object, position and rotation, just like it's a regular object. In other words, I created it, and it's not spinning or anything. I made it spin because you see this rotation right here is plus equals 0.1. That makes it spin. It wouldn't otherwise just be sitting there at the top. I made it spin around. So in other words, we have the same controls. All that stuff down below does is create this funny shaped object, and then you do whatever you want with it. Okay.
So I'm just curious, the BL in BL object, what does that stand for? Like by light, or is it just some arbitrary
No, because originally I was going to call it blob.
Oh, okay.
And I made the word object out of it.
So that was like just your variable.
Blobject, yeah, that's all.
Okay,
Yeah.
I wasn't sure if it was a universal term.
No, it's just a variable, just like anything you'd pick up. Yeah. The only thing with variables you have to be careful of is in this program, in my programs, is this right here. I've already defined old x. This is a big mistake, but I'm going to change this next semester. Old x. What if you created a variable called old x? It would conflict, and you'd never know why it didn't work, because there'd be two of them, and it wouldn't know what to do. So an old y. Now set mouse down. Those variables can all be changed. None of this stuff. The only ones you're stuck with are mouse down, mouse up, mouse drag, and mouse move. Those guys you're stuck with because they're part of the thing. I could put like a little underscore next to them or something to make them unique. I've thought about different ways of doing that, but like maybe using GR like graphics in front of everything. GR, mouse down, GR graphics, kind of thing. But I haven't done it, and so we have to be careful. Another thing, like right here, the word turn, for example. It's not unusual for someone to use the word turn in a variable. They could have done it, and it would crash with the one I had. So one of the problems that I never mentioned, I was hoping nobody would do it, nobody ever did, is they would never use a variable name as any of the variable names up here, which I've already used for stuff. Down here, another thing about this program, which you may not have noticed before, see that if statement right there. It says if total is greater than 385 and all that blah, blah, blah. That's the line, one of the two lines that keeps you from bouncing outside the walls. If you simply put two slashes in front of that line, that if, and two slashes in front of this line down here, which is another if which calls back and front, it's the same thing, you will no longer be limited by the walls. You can go as far as you want in any direction. So those are the only two lines that affect that. If you cut those out, you're free to go outside the walls. And that's it. That's what those lines do. You never have to add ambient because it's always there. But you do have to add left and right. Anything else you have to add because no other lighting is there, okay? But ambient, you can just remove it first. You can bring it back by saying add it later, but you can remove it. You don't have to add it. It doesn't affect anything. If you say add something that's already there, it doesn't hurt anything. It just ignores it. That's all. Okay, so that's that program, and I just wanted to put it there so that you'd have something that was, written outside the scope of what we've been working on, so you get to see what it looks like. Okay, to begin with, I'm only going to cover the first half of the course today, and I'm not going to cover everything. Our textbook is the website. It's got everything on it, every single thing. It not only has instructions, it has little programs, it has me blathering, it has all kinds of stuff that tells you how to do things. When you come to the final, if I were you, I'd bring a laptop. Now, as I mentioned below, you can access this web page and any of the reading stuff with your cell phone if you want. That's possible. But if you want to actually hear something or anything that requires a little more technology, see a program, for example. If you look at a program, it's so wide, your cell phone's not going to do it very well. So you should probably bring a laptop. It's easier for you to see everything. But you're welcome to bring a laptop or your cell phone or notes or anything you want, because the whole process here is not to, I really don't want you to have to program from scratch. I want you to be able to take tools and things and just assemble them into something that works. That's all I really think that we should accomplish in this course. So that means that if you have Google there with you, it's fine. Getting in touch with anybody during the exam is not a good idea. I'm saying that for you guys who are listening on here, because then you're not assembling the stuff, they're doing it, and that's the whole point. I'd like to have you do it, and that's the whole point of it. The information I don't care about. It's how you put it together, and that's your job, okay? Or and all the questions are either multiple choice or fill in the blanks. There might be short codes, computer code to write, but you'd just be filling in blanks in the code, just like those little assignments we did automatically. It's the same kind of stuff as that. And so that's what the homework's going to look like. So we first started off in the course. The first thing I did, let me get back to basics here. Back to the startup somehow. In the beginning, most of our time was spent in the first 3 days just trying to get Alta Vista to work. So obviously that's not the kind of thing I can really test you on very well. So I'm very unlikely to have any kind of questions involving Alta Vista. All the questions I'm going to have are going to involve actually writing code. There's three kinds of code we wrote. There's HTML, and you should know the basic layout of a web page. HTML, head, body, HTML, and then how to put the stuff, where to put everything in between. In the head section, we spent, in the beginning, all we were doing is just working in the body. We just simply says, here's the body, here's the background color, here's put all the text in the center, and here's what you want to, and we wrote and put pictures in, okay? You should know how to put images in, that's obvious, true, and how to center everything, okay? Text align, colon, center. These are style questions. So in the HTML, I went to style sheets right away because HTML itself is just very fundamental, but the style thing makes your font different, makes your colors different, make your background. So we went to all these style stuff. You should know the style. You should know the basics of style, how the style thing works. One thing that I covered in style along the way was the div, and we didn't do a lot with it, but essentially you can, as you know, you can make a div, which is like you open a chevron, right through a div, then you say style, and you write any kind of style you want, then you close it. And whatever you write after that on the page will follow that style. So if you centered it, it'll center. If you change the font color, it'll change it. It'll do all those things. And then when you say chevron / div, close chevron, it'll stop that. So in other words, everything after that first div will do what you want to do. Then when you say / div, it'll stop doing that. If you look on my webpage, on the webpage for the class, I use that many times throughout the webpage, just doing that exact thing. In fact, looking at the web page itself, You know, if you look behind the scenes of this webpage here, you'll see a lot of stuff that we've done that's kind of useful. You also see some stuff that might be technically, you know, way out there. Like this thing right here, style body, that kind of thing right there. What I did was, instead of putting the style in the body, I put it up above in a different place. You can actually do that. You can tell, you can anticipate what some of the style things are going to be. Down here, I inserted it right in line in the code. So you can see that stuff up here has been left behind, and down here I've taken over. In other words, whatever you do, the most recent thing you say is the one that dominates, whatever that is, okay? It'd be good to look at that new lightning thing I just added. It's right here. It's just a video, that's all it is, just a video. It auto plays, starts off. But the trick is, I forced it to be in the upper left-hand corner right here. I said put it in the upper left corner, and then does that say wad?
Yeah.
Does that say laughed?
Yeah.
Interesting. So it ignored it for some reason. That's very interesting. It should be left, obviously, and that should be width. But it worked. Width's 100%, height's 100%. So it must have done is it might have interpreted the 0 top, which is correct, and it must have it figured if that was left-hand top, it must have just imputed that for some reason. Wait a minute. No, it did it because it's the first thing there is. That's the first thing I threw out there. So it automatically would have been that position anyway. Those are typos. Amazing, it worked without them. I wish it hadn't because it looks stupid. And so, but the width 100% and height 100% is how you get something to go across the screen. Trouble was, if I went across the screen, it would have pushed all my words out of the way. So what I did is I indexed it, see the Z index right there at -1. So I dropped it back into the screen so all the words were on top of it. So the lightnings, all that stuff came to that. I cut the lightning off after about a couple of seconds because I didn't want it to bother you while you're going through your pages. But in fact, I may get rid of it because people are probably going nuts with it. The noise is what bothers everybody. But I mean, this web page here has a lot of stuff in it that I've used throughout the course, and there's stuff in it that's useful, different various kinds of things. Here's a paragraph here. Did we do that in class? P's, no, it's not. It's just take it like it's div. You can do the same thing. You set up a P, and then you set up the styles, blah, 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 whatever they happen to be. And then what you do is you right here, it just goes to here, style color red. All I did was change the color. That's all I did in the paragraph. And then everything here is going to be red until I bump into this /P right here and it stops being red. You know, it's amazing. They've almost got it now so you can put any word you want inside chevrons, and then you can slash it at the end and it'll work. I mean, there's so many words now. It's like a free-for-all out there. But none of these other things are important. So let me get back to what is important to us. Okay, so Alta Vista, that's what we started off with. I got through all that stuff. Uploading, that's all stuff you have to screencast. I'm not going to ask you a question on screencast. This thing right here is the thing you have to put. That's the thing you have to put in to make your programs work. If you're on a Mac, that doesn't work, by the way. You have to look up Mac, Google, Chrome, allow file access, and they'll give you whatever they have to do in the Mac is a different thing. Okay, there may not be anything. Maybe it just does it automatically. That would be pretty scary though. You should know about file extensions. You should know the .html, how to save, all that stuff, of course. JPEG, PNG. You should know PNG and the difference between them. Once you can have transparencies. PNG has a lot of other attributes, by the way, but we don't use them. The Z index, you should know what that is. I'm just trying to get to something here we actually started to cover. Transparencies, you should know how to do that pretty much. Images, you have to keep the size under 1,000. If you get over 1,000, it starts to slow your machine down. Up here, down in the city, in Seattle, it wouldn't bother you at all, but up here it's a mess. Some of these programs right here, these are the basic startup programs we did. And all they have, they're good code because they show you the basics of code. It shows you just what the code looks like, where the words go, and when you look on the screen, you see how it works. It gives you background color, yellow, and so forth. You can actually see how everything looks. These little programs are actually the highlight because if you use them, you can actually figure out a lot of things just from watching the codes. Spacing. This is one here that we haven't really talked about a lot, but this one has no spaces in it. But the next one, hopefully, this one has several spaces between the words. You couldn't do that by hitting spacebar, it wouldn't work. So what you have to do is you have to add in this little character right here, and ampersand in BSP. That's a space. And you just add a bunch of them in and it puts a bunch of spaces in there, okay? And that's pretty much, that's not a big thing, but, you know, I don't really know why they still do that. It seems like they would have gone to spacing, but there must be some technical reason. When they, one of the things they don't like to do is if they've made a decision not to do something, and then a couple of generations later when they don't have to do it anymore, they're worried that if they change it, it'll break all the programs that were previously written. That's bad. So they try to avoid that at all costs. So that's the reason why some of the things we're still stuck with, even though they look awful. But using HTTP, that's one of them. They'd love to get rid of that. In fact, you don't have to use it in Chrome. You just write you don't have to write www anything. Just write the website name and it attaches all the other stuff, which shows you how it didn't work. By the way, there was a time, and they still may do this on some browsers. There was a time when you could use your browser for an FTP, file transfer protocol, which they don't tend to do anymore. But FTP is different than a regular browser. Regularly what a browser does, it goes through this called the HTML and HTTP format. It transfers it back and forth between you and wherever it's stored in a certain way. File transfer is a whole different thing. File transfer will go in and get a whole bunch of data and bring it into your computer, or a whole bunch of data here and bring it to their computer. The file transfer is different. They used to be able to do that through the browser. And you might be able to type FTP still to this day, and it still might work in some browsers, I'm not sure. But it's something to get scared of because if you can transfer whole files, who knows what you could be doing. And they had to have, you didn't know the password of the people you were putting it on, so they had this thing called the anonymous password. You type in like your email, something, and then it would penetrate into their system and put stuff in there. But now in the age of viruses and everything, no one's crazy about that idea anymore. Anyway, that's what the spacing was. The z-index, all it is z hyphen index colon, and the z-index tells you how deep it is. If it's 0, it's right in the main page. If it's -1, it drops behind that page. -2 is further behind. +2 is forward. +1 is forward. They're all forward. So it basically goes 0 is the flat plane and everything else. It's like plus and minus, that's all. Above and below the plane. I'm going to skip the title one. This one here is the most important one here. If you wanted to put a background behind your words, a background image, you can do it with this instruction. Now this is a big rigmarole. This instruction is a lot of work. They used to have one that just simply said put background image. It was that simple. They've changed that a little bit because they've changed it into a style. And once you put something in a style, it's got a different format. But by the way, it's possible to do things like background and stuff in the old-fashioned way, and many times that'll still work. But I don't want to teach you that because if you want to go look it up, you can. But if I show you something that's going to die, right in the middle of something very important for you, it'll die, and they'll say it's not there anymore, and you'll go, it'll ruin your whole program. This thing right here is here forever, or for a long time. Basically, you say background hyphen image colon, then you have to put the letters URL, that's essential, open parentheses, and then what you have to do is write the name of the thing with no quotes around it, close parentheses, semicolon, go on to the next stuff. So in other words, if you want to put a background image, that's how you do it. Instead of just putting a background color, you can put a picture there of some kind. okay? And you don't want the picture to be just, tiled, like if it's only like maybe 400 by 300 or something, it would be 400 by 300, it would give you a tile version of all the picture. You want it to be across the entire background. Then what you do is you add this other stuff. Background size says cover, that's the magic word. Then they make a color for what's behind the thing, FFFF. Do you know which is that, white or black? White? White. All colors, everything's on is white, RGB, right? Text align center, that has nothing to do with the background at all. And font size is 100 pixels, that has nothing to do with it either. In other words, they got other things in this background thing. But the most important part of it is background image is blah, 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 and background size is cover. That tells it right there. I do it slightly differently. What I do is I say position absolute, put it up in the corner, and say width 100% with a percent sign, and height 100% with a percent sign, and that spreads it across the whole page. Anyway, that's something that's worth knowing, because you you sometimes have to do that. We're going to get into it here in a minute. Yeah. We never use the title, but you can use the title. Up in the head, you say HTML head, then you can put title inside of one of these things, and then write whatever the title is, then put / title to shut it off. It's just like a sandwich, just like all the other tags. Okay, but I don't use them because they clutter up the program a little bit. And I don't use metas either. The meta, the thing that meta is most useful for is that when Google wants to look at you to see what your, if they want to find out what your page is all about, they'll look at all the metas. They'll see what the page is all about, and then they'll so if you say, I'm looking for a new stove or something or other, they'll say, it says stove, new, yes, and then they'll throw that page to you. So the thing is, the metas are used for other things, but that's the one, where it really counts, is how Google treats it. I talked about input and output the first time right here, how to get stuff in and into a program. Basically, these programs are kind of cool. We just put hello, and then when you hit press me, it brings the hello back to you. So obviously, that program has to have something that listens to you and sends it back to you after you type it in. And so this is what that program looks like. It's very simple, but it introduces the basic idea of buttons and all that. It starts off with, it creates, the JavaScript language creates the first function we had. That's the first time we had a function up there. And so all of our functions were between script language and /script. That right there is the behind the scenes activity. Down here in the body was our visible activity. And so you have inputs, like for example, there's an input type text right here, an in text and a style and so forth. Basically, I'm sorry, I got the wrong one. This one right here says center the whole thing, give it a chartreuse as the color. That was chartreuse, that light green. And 30 pixels for the size. So that was the screen we actually saw right there. It says enter any phrase into this box. Those were the words I put in. And then it said the input box was this, and the output box. The input box and the output box are both inputs. They're called inputs because you can do it differently. But what I decided to do was I decided to make everything input. So we have an input box where people can type stuff into it. We have an input button, which simply was an input instruction with a button to it so you can go to the functions. And then I had an input statement, which is really an output statement. So what I did is, instead of having all these different statements, I just use one statement for everything. Turns out it works. This one right here is called in text. Whatever they type in to the inbox will be called in text. That's its name, in text. And then when you press the button right here, you send that in text dot value, because you're sending the value. You're not sending the length of it or any other quality. You're sending the information that's in that in text up to your function. You're going up to this function, which is called move. So you go up to move, and it brings it in as a name whatever, and then it says take whatever and put it in the out box, outtext.value, which is this input right here, which is the second input. All it simply does is goes from one input, moves it to the other one in JavaScript, and then quits the program and shows it to you down there. So it doesn't really, there's nothing much going on there. But that was the first time I think we used a program that used JavaScript, so that was pretty important. That's a program that's probably worth, if you haven't got enough practice looking at. This one right here, first and last name, introduce another idea. You say, what's your first name, what's your last name? Well, let me do it. Oh, Joe. Oh, no, Joe. And by the way, tabs do work between these things. They always work between them. You don't have to do anything about it. Press the button. Full name is Joe Dot. See what I did is I added those words to this name plus that name. I added them all together. And actually, add is exactly what I did. I said, I took the information down here, and then I jumped up to here with my first name and my last name, comma like that. And then I said, for the out text, say, quote, these words, blah, 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 unquote. There's a space right here too, but I notice that space, plus the first thing I typed in, which is this right here, the first name, plus a space, plus the last name. Those spaces are important because otherwise they'll all be jammed up. You have to put a space in. The spaces have to be inside quotes because that's what makes them spaces. Otherwise, there won't be any spaces there. So if I killed, for example, if I killed this space right here and I killed this space right here, everything would be jammed together. It wouldn't show on the screen otherwise. And so that right there is a good program because it has some simple ideas about presentation of plussing things together. If you have two numbers, that plus sign will add them together. 5 plus 6 will be added together. But if they're both strings, it'll just glue them together. Okay, strings are just words. Okay. By the way, if you said down in your program, you said, give me a number, and you put in 2, and then you said, give me another number, you put in 3, and then you sent those numbers up to a function and said, add them together, it would glue them together. It would get 23 is what you get, because you have to translate things into number. Remember we did that? It comes up as a string, and you have to say number with capital N, this thing. You have to change it into a number and put it into another variable, which is your numerical variable. Then you can add that thing. So you got to convert to numbers if you want to use them as numbers. That's always been a big problem in computing, is, and you can imagine what would happen like in sorting, when you sort stuff. Alphabetically, we don't even think about this because our brains are so fixed on how it works, is that alphabetically, it's different sorting things than it is for numbers. In numbers, the critical thing is like if you have 50 and 100, okay? Now the thing is, 5 is a bigger number than 100. So in terms of words, the 5 would be high and the 100 would be low. But in terms of numbers, not so. We count the digits, so it's the reverse thing. Numerical sorting and alpha sorting are totally different things. They're completely weird. So you have to think about it a little bit to understand. What it means is numbers, alphabetical things are left justified when they're sorted. All of the things are pushed up to the left. So all the A's and B's and C's, that's what decides the main categories. And numbers is totally different. They shove that away, so they're right justified. So therefore, when it hits the 100, that's a higher thing. That's way up there. It knows, oh, this is big. And the next one's littler and littler and littler, like that. So they have totally different ways of sorting. Actually, they would probably sort right to left to get it to do the right thing. But sorting is one of the reasons why you have to distinguish between numbers and words. This day here, day 6, gives you all the arithmetic stuff. Add, subtract, multiply, divide. That's all we do. And it shows you what you have to do. Let's just do one. You look at one of them here. They're all in this one. So it's enter a number, so I'll put in 4, and a second number is 6. You can add them up, and you get 10. You can subtract first from the second, you get -2, and multiply them, and you can divide them. Or you can look at the program and see what it works like. And there it is right there. Each one of these functions, you add A and B. Notice it has to change A to a number. See right there? Number, it takes A and turns it into a number. And this one takes B and turns it into a number. Then it adds them up and puts it in a numerical variable. No, they have to be, you have to put that number in front of it to make that into an, otherwise it'll give you A glued to B, that's all. It won't give you what you want. That's that. And the division multiplies at asterisk, division's a slash, plus and minus are add and subtract. There's some other, they have percent signs, they have other things, but we never use them, so I'm not going to worry about them. Too mathy. Let's go down here. Then we started talking about languages. Let's go to this one here. This one right here will be good. We have some, well, it's probably not a good program. Hang on, I'll get one that you don't have to know anything. I don't like ones where you have to know something. This one right here. You're at the International Airport. If you press American, nothing happens. Press British, nothing happens. What's wrong with this thing? This program is a complete failure. What do we got here?
Your flight is departing at 8:02.
What? Oh, I should. Thank you. Thank you. How'd you know that? You can't even see it and you knew it. Okay, here we go. Let's try it now. Such a genius.
Good morning.
Morning.
Your flight is departing at gate 2.
Bonjour, votre vol est 42.
Yeah. So how does it work? Basically, we have a language synthesizer right here. It's called, in NewTalk, you have to put this line right here into your code. And what that does is it brings in this thing that you can send, this function called with accent. You can send it a bunch of words, comma, and the language you want it to be in. And in this case right here, when you want to speak American, we arrive up here in the American, when you press the American button, it goes here. It says with accent, and it puts the words here in English. Then it puts comma, then EN's -US. That's the code that says it's going to be in American English, okay? If we went to British, it would go to the same function, send the same words up there, and put it ENGB, which is the British. The French is quite different. You say with accent, and of course you have to put the French words, and then you put the French code, and it says it that way. Interestingly, these languages, if I put English, like an English expression right here and send it to the French, they would still be able to say it with basically speaking English with a French accent, which is kind of cool. I figured actors could probably do that to train themselves. Just take this program and run some, how they say the accent. There are lots and lots of accents. This previous click on this page would give you a list of all the accents. Let me just go to it here. Here's all the language codes right here. It lists them out for you, okay? I'm not going to go back because it will make the thunder again. Let me shut that off forward. Now that we've heard the accents, kill that thunder. Okay. This is a program here that actually is different than the other one. This one here listens to you, and it writes down what you say. It just requires a different include file. It's right here. Can you read that? It says listen.js, that's the one. And what that does is that gives you what you need to have the thing listen. What happens is, you don't have to press any buttons to go to it. What happens is you say blah, 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 and it's listening already as soon as the program starts. Now, the only thing about this is Google's been kind of stingy about letting everybody use it. So they give you a few minutes of it, and if you don't talk, it dies. It just cuts out on you. And that's why I have this button down here that tries to bring it back. It doesn't always work, by the way. I haven't figured out how to get around that yet. But basically, that's how your function works. As soon as you put this in, if you want the thing to listen to you, what you do is you have it go to a function called listen. You put this function, it's got to be called listen. And whenever you say something, it'll determine what it is in text and come to that function. And then it will bring you this thing called transcription, which is the text of what you've said. I take that text usually and put it into my own variable. Transcription is my own variable too, by the way, but I put it into my words so that if I want to do anything with it, I won't be interfering with future stuff that they're doing with these words. Sometimes they have a hard time figuring out what you're saying. So you say blah, blah, and it says, here's what you're saying, and you start to deal with it, and they say, oh, no, here's what you're saying, and both of you are fiddling with the same variable, not a good idea. So I immediately pull the stuff from their variable, put it in mine, and then I start dealing with that. So all I simply do in this program is simply take the words and put them in the out, in this in button, right, out one right here. It just simply puts the words in the out input area. Nothing going on there. So you can see what they're saying. Any program you use that uses this right here, listen, where the thing's listening to you, I would strongly advise you to print out on the screen what you think they said, because if they're asking for directions or something and it didn't understand them, they'll give directions to the wrong place. But if they see that it didn't understand them, they can simply repeat it, get the right directions. So I always like to have text showing them what they said. Get it? Whatever. This one here is kind of a simple one, but it's worth looking at because of the way it is so simple. If I go back here again, I press the up button.
You press the up button.
Press the down button.
You press the down button.
And if you look at the program, it's a very simple program. Basically, it's got these 4 buttons, and when you press one of the buttons, it goes to either up, left, right, or down. And then it says, well, it goes to speak to me. Sorry, it goes to speak to me. It sends the word up, left, right, or down. And when it gets up there, it says, well, if the word they sent right here is up, then say this to them. If it's left, say that to them. If it's right, say that to them. All with accent does is it makes it say these words with this accent right here. And that's all there is to it. Not much going on there, but it's kind of cool. It's just a simple little program. You press the button, and it says the words to you. We could use that in our 3D graphics easily. You could press it, and when it goes to the if statement, it could say, you know, there we go. What are you doing? Das ist schnell, verboten. If statements. They're very important.
You said that you are tall.
Oh, I shut the sound off. It would have said you are tall. I had to say it to you. Okay, but it didn't say it because I have the talk on. I had turned it on. So basically, here's the thing I was pointing out. Actually, I should do it. I should actually do this because it's important that you hear this one, okay? I'm going to go back to it again. Okay, if I say tall.
You said that you are tall.
Supposing I write this.
You said that you are short.
Because what it's doing in this program is not just saying if the words they say are short or if the words they say are tall. What it's doing is saying, look for the word tall, look for the word short. And if you find either one of them, then you give them an answer. And that program looks like this. It's slightly different. It uses this thing called index of right there, which is something we use. Basically, what happens is I say take their answer and look in their answer for the word tall. And if you find it, put a number in here. Any number you get from 0 to infinity it's there. If you get a minus number, it means it's not there. So in other words, if it finds the word, it's there. So in other words, one of these two guys here is going to have, if they said either one of those words, is going to have a positive number. So all down here I said, well, if the first variable right there, which is just a number, is greater than or equal to 0, then they said that. So what I do is I say with accent, blah, 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 you are tall. And if the second one, which was the second answer, had the word short in it, I say, blah, 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 you are tall. So you are short. So basically, all this simply is an if statement, but it goes a little bit further than an if statement. It doesn't say if these two things are equal. It says, first of all, find a number where the location is of the words they said, and then if that number is greater than 0, they said those words. And if this number is greater than 0, they said those words. And the whole point of it is, the if statement can tell you whether they said a word on its own, but it can't tell you if they said that word in a blob of a whole sentence or phrase. This can actually separate them out. So it's a much more powerful if statement for using it with words. Here we go again. This program here, the practice program, so this is probably worth looking at. Okay, like into 4 and tab 6. For B, 6. Type in your test symbols here. If A is greater than B, how about that? It's greater than, if I can find it. Run. Oh, run. Do this stuff. Yeah, because A is greater than B. That's not true. Did I do that right? Oh, okay. Print, print X. No, it doesn't. They can't do that. Can't do that to be an alert. I don't know if it would do that or not. Try it. I think I wrote this thing last year. I wish I had. Wish I would. Type your test symbols in here. Oh, is that strings? That's a number. Well, that's interesting. Don't use this program. It just failed on me right in front of me. I said greater than. 4 is obviously not greater than 6. Do that. Run. It says do this stuff. It should not do this stuff. Boy, I don't know how I ever did. I don't know where that came from. Let's see if this one works. I hope it does. Okay, apple. This one here says banana. Decimals in here. Try it again. Greater than. Run. That didn't work either. I'll look at this program. Sorry guys, I can't let this go. I gotta see what's wrong with this thing. Not B one's a number. Plus 2, 3. Oh, this is a complicated program. It's such an easy program. A is equal to, greater than, right there. Huh, it didn't fail. I'll have to look at that program. Something's wrong with it. I love that. That program worked for years. I don't know what's wrong with it. Something's going wrong there. Don't run that if program. I'm not going to do it for you. Video explains how to use the proximity function. Yeah, this is quick and easy. It's just I don't want to use the video though. I want to get a program right here. If you have 2 points on the screen, and you know the XY of one point and the XY of the other one, if you say proximity, open parentheses, x comma y comma x2 comma y2, it'll give you the distance in pixels between those 2 points. So that actually is worth something, because if you're using your mouse and you try to click on an object on the screen, if you know where the object is and you know you clicked your mouse, you can find out whether you're close enough to the object. Say, if the proximity distance is short enough, then do what you have to do. If it isn't, don't do anything. So in other words, it's a question of proximity, just tells you how close you are to an object. Here's the 4 mouse commands, by the way, which, let's get to the movie again. Right here. These are the 4 mouse commands here. You can, if you put the mouse down, I'm going to press it down now, left mouse down. You see it shows where it went down. And then I'm going to drag it along. I'm dragging it. You can see 32829, dragging it there. And then when I let up on it, it lets up and it leaves it, wherever you drag, it stays in that spot. So basically, what this thing does is allows you to move. You can move it without putting the mouse down. You see the mouse move is showing you. So all this thing does is tell you, where did your mouse go down? Where did it come up? Where are you moving it to without where you're dragging it to? It tells you those 4 things. Because it's got the 4 mouse commands in there, that's all, which is mouse down, mouse up, mouse move, and mouse drag. So all it does is it looks at the variables. And by the way, those variables are important. And mouse down, sorry, the variable is mouse x1 and mouse y1, like that. On mouse up, it's mouse x2, mouse y2. On mouse move, it's x3 and y3. And on drag, it's xd and yd. What those are is, those are the actual locations of the mouse. If you go to the drag point, it says this is where the mouse is while you're dragging. If you went to the move function, mouse x3 tells you where the mouse was during the move function. So not only does it tell you when you go to these functions, it tells you where the mouse is located and that you have in fact done a drag or a move or something. So it gives you that stuff to work with. This program's just a silly program, just a program. We did a bunch of drag stuff, and I think the programs were a matter of pressing the mouse down, telling the computer it's down, performing the drag, and then when you let go of the mouse, it stops doing the drag. But the first step of this program here is how close are you clicking the mouse to here? So if I click the mouse over here, for example, and drag, it's not going to do anything, because I did a proximity and the distance between here and this box is so great it doesn't do anything. If I click down close to it, then it says, yeah, the proximity is very close, so therefore when I drag, it now allows the drag until I let up, and then it doesn't drag anymore, and if I click somewhere else, it doesn't drag anymore. So basically this is just using the 4 mouse commands with the proximity to determine how close you are. The drag is simple. I move the mouse a certain distance this way and dragging it, then I just move the object the same distance dragging it. That's all I do. Just actually move. Well, are we getting 3 o'clock already? Okay, let's keep going here. Click on the buttons, not important. Music, that's a new thing we started doing. Let me go to the program itself. This has got a video in it as well as music. There's 2 different things going on here. Here's the sound part, the audio part right here. And it simply does is it auto plays and it loops. So basically, if you have any song or something you want in the background, this is the code line you'd use right here. The name of the music or whatever. Then you put autoplay and loop, and it would keep playing over and over again. The video, it's a video line. You put down the name of the video, and you also can say autoplay loop there too, and it will do the same thing. It'll play the video and play it over and over again. If you say autoplay, if you don't say either one of these things, it won't start until you tell it to start. It will only start when you tell it to get going. It's almost the same code you use for your webcam, but I'll get to that in a second here. Get back. So that's how the video stuff is and the audio stuff is brought in. This one right here is combining everything. It's combining the mouse down, only I'm placing it down where the video image is, and I'm dragging, and I just simply relocate the video image because I have an absolute left, top and left, and I just move it to a new location when I drag it around. Webcam, you can't use the webcam in Chrome, but you can use it in Firefox. And basically, here's a demonstration of webcam program. You can take that code, it'll work anywhere, it's universal. And so you could have your own programs with it would work perfectly well. As long as they ran it in Firefox, it would work. And all it does is, that's one of the better of the two. There's two or three of them here, but the better of the two is person to person. What you do is you run the program. It says to you, what code do you want to use? You type in the code, and you say start. And the other person, if they type in the code and say join, it'll link you both together by video. Okay. The only problem I had with it is that the sound doesn't. You got to use earphones because the sound comes out your speaker and goes back in. You get a feedback loop. It's probably not a good way to go, but that works. That's a very simple program. You can add that to anything you have. Some of these are just kind of cutesy. They don't do anything. This right here, hang on. Wait a minute. Right here. What this program does is it makes Pig Latin out of anything you type in here. And the way it works is it uses these string functions. I'm going to let you just find these yourself. One of them is substr right there, S-U-B-S-T-R, and the other one's called substring right here. There's two different functions. And there's actually a program, somehow I missed it up above. Let me see if I can get to it. There's a program that actually shows you the difference between them. You run the program. On the 3D graphics. Capacity, hang on, it must be up above here. Must be down below, hang on. Gotta find the thing. Right here. The way this program works is you should run it. It's actually what it does is it tells you how substring right there works and how substr works. What you do is you type in any string you want to type in up here, and then you type in two things. You type in where the position you want to look at, the beginning of it, and the position you want to look at the end of it, like for example 2 to 8, you want to look at everything from 2 to 8. It's not going to find that. It's going to find everything from 2 to 7, and it's going to put it down here. For some reason it goes short of the high number. Okay, that's what substring does. Substr is much better, but it goes from position and length. You say, I want to take everything from position 7, I want 12 characters. It'll take all the 12 characters. So that one will take a different chunk out. So this one goes position to position. This one goes position and number of characters. But they're both very handy to use. You can use them for lots of different things. We never wrote many programs on them because at that point we were just about ready to get into 3D graphics, which is where I am now. That's what I'll pick up on next time. We'll just talk about that more. And that's pretty much what we covered. You should look at those pages and those programs I just went through to see how they work and kind of get a feel for anything that you, or if you've got them down pretty pat, when we do the exam you'll be able to. By the way, bring your laptop with you, as I said. I think you should bring one. If you haven't got a laptop, you can bring one. The library lends them out, but you have to probably order them ahead. So be careful you don't go at the last minute. That's pretty much it. I'll be here for a while if you need anything.